So the magnetic pole in the north right now is racing across the Arctic Ocean towards Siberia. It had been relatively stable for a couple of thousand years with very minor movement. We're talking between 1 to 3 kilometers over a decade's time. That is not a lot of movement. Now we're seeing 40, 50, 60 kilometers every year of movement. And as it is heading across the North Pole towards Siberia, the southern magnetic pole is moving as well. Now, it's not moving as quickly, although it did have an acceleration in the last 15 years, and it's still accelerating. I'm interested to see what happens over the next 5 years. But even though it's moving more slowly, it is further away from the geographic pole than the north magnetic pole is. So you could say it's already further ahead in the race. It's just it's not running as quickly right now. It has already left the continent of Antarctica.
Right. It's outside of the Arctic Circle.
It is outside, and it is heading towards the Indian Ocean.
Yeah, and so it might take a little while for that to catch up to what the northern magnetic pole is.
It might or it might not. Okay. These accelerations happen pretty dramatically, and there's one study on this, and it's by some of the best in the field, and they say that when things really kick in, they will be moving, the magnetic poles will be shifting, the magnetic field will be changing at 100 times the rate that it is today. And just to give you an idea, if you consider approximately the middle of the 1800s is when this began, and that would be when we were at full strength. From the middle of the 1800s up to the year 2000, so call it 150 years, we lost 10% of the strength of Earth's magnetic field. They updated that number again in 2010 to 15%. So it took us 150 years to lose 10%, but only another 10 years to lose 5, which would extrapolate that out 20 years to lose that same 10% as it had taken 150 years before. That's a very extreme acceleration. And one more acceleration like that, and we're talking about, hey, the poles could be moving hundreds of kilometers a year. These things could be months away from actually hitting the magnetic reversal point and sending absolutely everything into chaos. And so the real question, and the reason why there's that window, I don't know if it's 10 years from now, 18 years from now, 25 years from now, is because I don't know when that next acceleration is going to occur. If something terrible happened and it happened tomorrow, we might not see 2027. I don't think that's going to be the case. There's no evidence to suggest that, but 2006 was a big one. 2023 was a big one. We're probably due for another one of those about 2040. And so either 2030, 2035, or 2040, we should have one of those major accelerations. And at that point, there really isn't much time left. Things are going to be growing chaotic very quickly on the planet.
Okay. And how do we know that the magnetic poles have been relatively stable for the last couple of thousand years?
We can go and see some of the accelerations are happening approximately every 4 to 7 years. Sometimes they're very small, sometimes they're very dramatic. The next one we should be having is close to 2030. And after that, it would be 2035 or so. Those ones based on the pattern of how things have been changing over time, because we have the data on this going back with pretty good detail actually into the 90s. So we can see when some of these major accelerations occurred.